going to be learning about solving logarithmic functions, solving common log, and natural log.
Now we have the vocabulary of 4.3. We're going to start off with the logarithmic function, which is the inverse of an exponential function. So the way we write this out is log base b of x, which is an inverse of b to x. Up next we have common log, which is a transformation of the logarithmic function, but with the base of 10. Log base 10 to the x. Then there is natural log, which is the second transformation of the logarithmic function with the base of e. You're right, as so. Alright, so let's start with some examples, even though we're going to see some later in the video. That's why we get these started, and so you're not confused when you see them. So for a logarithmic function, example of that would be log base of 4 to 16. What will that equal? 2. Because 4 squared equals 16. Second example of a common log with our base of 10. So let's do that with the log base of 10 of 1000. So 10 cubed would equal 1000. Now for natural log, our base of e. This one we're going to need our calculators, so I hope you got them ready. Log base e. Let's just throw in 4. For the sake of simplicity, plug that into your calculator. You will get 1.386, etc.
On the first example at logarithm functions 4.3, we do 6 to the power of 2, that's 36, which is equivalent to log 6, parentheses 32 equals 2. And that's how you set up first example number 1. Example number 2, you're going to need to put log 4, parentheses out of 4 equals half, which is equivalent to log 2, parentheses 4 equals 2. So in example number 3, you're going to solve for x. So right here, log 6, and x equals 2. X is power 2, and that equals 36. So for example number 4, you could use the calculators for this. It's compatible for it. And right here, you're going to rewrite the expression as a long-range theorem, and we get the equation. So we put 4 x equals 16, which is equal to x equals log 4, parentheses 16. And that's it.
Alright, so now we'll be focusing on common log. So with the common log, it'll have the base as 10. So the equation would be it could be written out as log is 10x. So an example would be log 10 to 10. So now we have to find the log number, which is the answer. So you just plug this into your calculator, and you'll get it equal to 1.
For these two examples, we're asked to evaluate the common logarithms using a calculator. The reason we're asked to use a calculator is because notice how the number part of the logarithms cannot be written as 10 raised to an integer power. So we'll have to get decimal approximations for these common logarithms. So for the common log of 110, with the calculator, we'll press the common log, which is this button here, 110, close parenthesis, and press enter. We're asked to round to 4 decimal places, so this will be approximately 2.0414.
Alright, so now we're going to deal with natural log. And natural log has a base of e, and e will equal to 2.671. It can be written as ln to the ex, actually, my bad. And this also means log e to the x. Okay, so an example would be L and E. Alright, so you just gotta plug that into your calculator and you'll get 1. Also, another example would be L n to the 4. You plug that into your calculator and you get 4.
Calculator out. Let me get the TI-85 out. And different calculators will have different ways of doing it. If you have a graphing calculator like this, you can type in the statement natural log of 67 and then evaluate it. So here this is a button for ln, means natural log, log natural maybe, ln of 67, and then you press enter and it'll give you the answer. If you don't have a graphing calculator, you might have to press 67 and then press natural log to give you the answer. But the graphing calculator, you can literally type it in the way that you would write it out. And then you press enter, so 4.20469, and we want to round to the nearest thousand. So this is a thousandths place right here, this 4. The digit after that is 5 or larger, to 6, so we're going to round up. So this is 4.205. So this is